Now that we have clarified the difference between energy and power, let's zoom out and look at the bigger picture. What exactly is an energy system? Let's take a look at what makes up a typical energy system. It starts with generation, where energy is produced. This could be a solar farm, a wind park, or even a conventional power plant running on fossil fuels. From there, electricity travels through the transmission grid, those tall towers that carry high voltage power across long distances. Along the way, transformers are used to step voltage up or down, depending on the stage of the system. High voltage for transmission and low voltage for local distribution. Once electricity reaches population centers, it enters the distribution network, which routes power directly into homes, factories, and businesses. In this example, you can also see battery storage supporting the system, a growing part of modern energy networks. From generation to consumption, this entire journey is what we call an energy system, a network of technologies that work together to ensure electricity is delivered where and when it's needed. So what's actually flowing through this system? In physical terms, it's the movement of electrons, what we call an electric current. And it's driven by voltage. You can think of voltage as the pressure that pushes electrons through a conductor, while current is the actual flow of those electrons. Along the way, electricity faces resistance, just like water faces friction in a pipe. The higher the resistance and the longer the wire, the more energy is lost as heat. That's why we use high voltage transmission. It allows the same amount of power to be delivered with much lower current, and lower current means less resistance loss over long distances. But high voltage also comes with serious safety risks. It's extremely dangerous and can be deadly if touched. That's why voltage is stepped down through transformers before entering homes and buildings, not just to match the appliances we use, but to ensure safety. You don't need to be an electrical engineer to understand energy systems, but having a rough sense of what's physically happening helps build intuition for everything that comes next. A functioning energy system isn't just about power plants and wires. Behind the scenes, there's an entire support structure that makes everything work smoothly, both technically and institutionally. First, we have control systems. These are operated by grid operators who monitor the system in real time, adjusting supply and demand every second. One of their key responsibilities is to keep the system's frequency stable, which reflects how well supply matches demand. Then there are storage systems, like batteries and pumped hydro. These help by storing excess electricity, releasing it during peak demand, and balancing the variability of renewable generation. Next, we have markets and rules. These govern how electricity prices are set, which plants are selected to generate power, a process known as dispatch, and what kinds of projects get built. They also provide investment signals and help ensure fair access to the grid. When these elements work together, we achieve strong system outcomes. Electricity is delivered reliably and securely. The system remains efficient and it can quickly respond to changing needs. All of this coordination between physical infrastructure and institutional frameworks is what turns wires and electrons into a reliable, responsive, and modern energy system.